This is a video presentation documenting the weather balloon launch of the Environmental STEM class of 2021. The first step in our process was the preparation. This year we were led by Mr. Anderson and Mr. Dickman and had a little bit of help from Mr. Moore in the woodshop. Now, in order to formulate the perfect plan and execution for our launch, we needed to separate into different teams. First, there was Bobby and Harrison in charge of the probes. Next, taking care of the balloon cameras and its inflation was Andrew Groviak and Dominic. In charge of the flight train was Warren and Ben. Tillahoon was responsible for the flight computer and payload construction. Danny was in charge of the spot tracker and beeper. Will took care of the drone video, and finally I, Andrew Munie, helped with the payload construction and was responsible for taking photos. The preparation process lasted a few weeks, no thanks to some unfortunate weather that set us back quite a bit, but nonetheless we were able to launch on February 28th. Here are some pictures that documented the day. Once we sent the balloon up, the payload was taking pictures from 3 different angles: up, down, and to the side. Despite our goal to reach 100,000 feet in altitude, another unfortunate setback caused a different outcome. Above Talmaco, Illinois, at 16,756 meters, or 54,974 feet, the balloon itself actually ripped away from the payload, marking its official maximum altitude. The payload finally landed near Highway 45 south of Effingham, Illinois. By my estimates, Mr. Anderson and Mr. Dickman drove about 100 miles in an hour and a half to get there. Upon retrieving the payload and collected data, we were able to analyze the numbers we found with graphs and compare them to previous launches. This first graph compares the payload's speed and altitude. The blue line represents this year's launch, while the red and orange lines represent the launches of winter 2019 and summer 2019, respectively. Although there is no clear trend, we can see that the payload speed fluctuates dramatically over the course of the launch, especially in the case of winter 2019. The next graph compares altitude and temperature. As we can clearly see, all 3 graphs show how the temperature decreases as altitude increases. This graph shows the relationship between altitude and pressure. Interestingly, there was no significant change between the 3 launches. In fact, you can hardly tell the difference between this year's launch and the winter of 2019. This graph compares altitude and the percent of relative humidity. Despite the repetitive fluctuations, all 3 launches show a general trend of relative humidity decreasing as altitude increases. This next graph compares oxygen levels and altitude. These simple graphs clearly show that as altitude increases, the percent of oxygen in the air decreases, which is what we would expect. The only exception here is in the summer of 2019 launch. I believe we can account this outlier to the difference in weather between the summer and winter launches. This year was our first and therefore only year so far measuring ozone levels in the atmosphere. This graph comparing those levels to the altitude shows no specific trends. However, we do see two major spikes around altitudes 2,000 meters and 12,500 meters. This graph compares the altitude to the UVA. Despite the very dramatic peaks and fast frequency of the changes, we can see that all three launches show a general increase in UVA as the altitude increases. The same thing is true for this graph that shows the relationship between altitude and UVB. I believe that there are positive correlations in each of these graphs because as the payload increases in altitude, the closer it is to the sun, and therefore we can expect a higher intensity of UVA and UVB rays. I will admit, however, that I do not know why this year's launch looks so different in the UVB graph compared to the winter of 2019 and summer of 2019. Next, we will look at certain aspects of the weather balloon launches over the years in a longitudinal climate study. This first graph looks at the maximum wind speed over the years ranging from 2016 to 2021. Although there is no clear overall trend, we can identify how the summer launches average a lower maximum wind speed than the winter launches. The next graph looks at the altitude at these maximum wind speeds. Again, there is no general trend, but the average altitude in the summer launches is lower. However, it is interesting to see how the past 4 launches have dramatically changed that expectation. This graph shows the altitude of change in temperature pattern over the years. This chart shows how consistently the summer launches average a higher altitude than the winter launches with respect to the change in temperature patterns. This next chart shows the temperature at the highest point of altitude over the years. It is interesting to see how this temperature has gotten increasingly warmer just in the short time frame from 2016 to 2021. I assume we can attribute this trend to the climate change on Earth. These final images look at this year's weather balloon's flight path, as well as all of the locations in which the payload has landed over the years.